There are other ways of generating program graphs than the method we have used so far. Let us take a look at the online system once again. In the left column, there is a choice between whether the program graph should be non-deterministic or deterministic. So far, we have always assumed that our program graphs are non-deterministic, and this is the default when you start the system. For a non-deterministic program, like the one shown here, the system shows a red symbol whenever it performs a non-deterministic choice. By clicking the red symbol, you can force the system to reconsider its non-deterministic choice. Let us recall the way we generate program graphs for choice. If both Boolean conditions B1 and B2 hold on some memory, the system decides in a non-deterministic way where to go. If instead we want a deterministic semantics, we can modify the construction. This is shown here, where the condition for taking the second alternative is modified so that it will only be taken if the first one was not possible. This type of program graph is supported by the system by clicking the deterministic generation. For another example, let us consider what happens if neither B1 nor B2 is true. Then we are stuck at the start node. An alternative would be to be inspired with what we did for iteration and have an edge from the start node to the end node that can be taken whenever none of the Boolean conditions hold. This is shown here, but this modification is not supported by the system. The online system lets you decide whether or not the program graph for a program like the one shown here should be non-deterministic or deterministic. Now is the time for you to use the online system to figure out how many execution sequences do we have, depending on whether the program graph is non-deterministic or deterministic. Although the system does not support the generation of evolving program graphs, you can modify the program yourself to obtain the same effect. Show how to do so. Finally, consider that we have only discussed conditionals so far. Do we need to make similar modifications for iteration? Once you're done, you should read the section in the book, doing the try it outs on the way.